live. Yes. So, good day, everyone. How are you all doing today? I think we should wait for another few minutes or few seconds that people join in. So, guys, please let us know where are you joining from. I'm from Delhi, India, and Andres is joining from Argentina. Somebody is joining from Texas, and then we have Ranchi, India. The many folks who are from Ranchi I can see here. Argentina too. Austria, people are saying hello, hello. Hello from Finland. So I think we can start. So, good day, everyone. I hope you all are doing good today. Hope all you are having a great time here, like me, and enjoying the conferences. Last 2 days, we had some of the best industry leaders with us who shared some amazing insights. And we have a lot more in the store for today as well. I'm Kavita Joshi, Product Marketing Manager at Lambda Test, and I'll be your host for this session today. Joining me today is Andres Sacco, who is a technical leader, a writer, and speaker. He has presented at multiple international conferences. He has served as a technical reviewer for leading publications, has authored a lot of books, and has contributed to Scala projects also. Our top topic is Houston, we have problems with the queries. In this session, Andres will be talking about the challenges of query performance and how they impact the APIs. We'll also look on the problematic joins and queries that have made without using frameworks. So guys, before starting, let me quickly give you a quick roundabout few ground rules we're gonna follow. So this session is being recorded. So in case you need to drop off in the mid, you can, and you'll be able to rewatch the entire session from the TestMu event by going to the schedule. Next, we'll be having a dedicated Q&A round towards the end. So feel free to address any questions during the session in the Q&A window on the right side of the screen. You can also react to the session at any time through the emojis or on the bottom of the screen. Also, guys, I would request you to please keep the session engaging. Having said that, join me in welcoming our speaker, Andres Sacco. Andres, over to you now.
Thank you for the kind presentation. I will contract to you by present me in another event. Well, let's start with my presentation because we don't have all the time of the life to eat my presentation. So, okay, the title of my presentation is Houston, we have a problem. And perhaps the title sounds funny for you because you listen in a movie or in any of this kind of image that are around of internet about jokes. But the problem behind the scenes is not a joke. So as my host present me, my name is Andres Sacco. I work since 2007 using different languages. Most of them are connected with the JVM, like Java, Scala, and Kotlin, and other languages. Also participate as technical reviewer on some editorials and publish some courses and books. Some of them appear at the bottom of the presentation, and I participate on different conferences around the world. I put on my presentation my contact information. So in the case that you have a question and now you don't know how to ask me, send me an email or contact me by LinkedIn, and I will try to help you to solve your problem. So let's start with the context of our problem. So we have a microservices which have some performance issues. And what imply these performance issues? Well, an endpoint takes more time to respond. Imagine that you create an application, everything it's okay, you deploy on production. After some weeks, everything looks fine for you, no problem. You start to introduce modifications or add new features on these microservices, and nothing happened. But at some point of the time, the microservices start to take more time to give you an answer. I do just a quick, just a simple request to an endpoint, and takes a lot of time to give me a response. And you say, you think, okay, why this happened to me? Because I don't change nothing, or everything looks fine. And the second problem that could appear is increase the latency in the platform. Imagine that your endpoint, or one particular endpoint on the platform, takes more time to give you a response. Imagine when you launch, when you deploy the first time, the microservices takes 1 second to give you a response. And now takes, I don't know, 5 seconds. This time, this extra time that takes to give me a response imply, in the case of Java, more uses of the resources, increase the latency. So the microservices or the application that needs something for our application take more time to give you a response. As I mentioned, increase the use of resources. And why this is so important? In the case of the JVM application, like Scala, Kotlin, Java, Clojure, Groovy, and many more, you create a thread that implies the use or you allocate memory and CPU. So if you take too many time to give you a response, you allocate this memory and CPU for many milliseconds or seconds. And some point will affect the performance of the microservices. And the next problem is it's not simple to find what is the origin of the problem, because again, you start to commit new changes, deploy new features, and you can say, okay, the problem is this feature, this commit. It's so difficult to find the origin of the problem. So how you can find the problem? Okay, we have a problem, and now we need to find a way to detect. The first way to do it is you can create an end-to-end test. Okay, I will create a scenario where I send a request to an endpoint and check if the response is okay, just to check if everything works fine. It's the first approach that I can do. Perhaps if you have lucky, you detect something in the logs, perhaps not. The second one is to create a performance test. Okay, perhaps the problem is connected in some way with the number of requests that my API receives at the same time. So I create a scenario with JMeter or Kotlin and say, okay, I will send, I don't know, 100 requests to this endpoint with this payload and check the results. Okay, perhaps it's connected, or you restrict the problem on the quantity or the amount of requests that your API receives. This is the second approach. The next approach is, okay, you can use tools like APM, like New Relic, Dynatrace to check the trace of the different layers that are executed on an application to detect, okay, on this layer, on these microservices, or on this part, and the application takes more time to be executed. So you have some clues about where could be the problem. Not why, where. You don't know the reason. And the last one, in the case that you don't have APM, you can have logs and include logs on each layer of your application to detect the problem. Okay, how many seconds or milliseconds take to execute this entire block of logic, and or this access to the database, or this connection to another microservices. So in some way, all these possible alternative is a way to have clues about where could be the problem. So why this approach is could fail because I show you 4 different alternatives. The first is because it's difficult to find where is the problem. In a distributed architecture where you have many microservices, where you have many layers on your application with a lot of queries, so it's difficult to say, okay, this part or this part is the problem, and this particular query is the problem. It's difficult for us to find the problem. The second one is, okay, something is wrong here in this layer. Why? I don't know. I don't understand why this query with the data that do something on the database works in a bad way. Which are the problems connected? Because we are not expert on database, or most of us are not expert on the database, on the performance issues in a query. Most of us perhaps know, okay, how execute a simple query with join many tables, but okay, if you do these kind of things, will affect the performance. It's complex. And the last one, it's difficult to find or check if not occur again. And the main problem is you discover a problem, you fix it, and how we can check if this situation not will happen again in the future. Because you fix it a problem, a particular problem, but you have a lot of microservices, a lot of queries on your applications, and okay, I fixed just one query on my microservices, and the rest, how I will check that in the future someone not introduce the same problem again. And there are many tools to do this. JFrogUnit, QuickPerform, and Kotlin and JMeter. And here you have a table which compare all of them. To detect a problem on performance, all of them help you. JFrogUnit offers the possibility to analyze block of code to detect performance issues, the allocation of the memory, and many other things. QuickPerform too. And Kotlin and JMeter in another way, but help you to detect problem on performance because you do like a performance test. It's simple to implement. All of them cover the same because are simple to implement. In the case of JMeter and Kotlin, you can do outside of your application and could do a developer, a tester, a QA, anyone that more or less know the syntax. In the case of JFrogUnit, a QuickPerform need to add some dependencies, but are not so complex. To check the problem on the queries, just one of them is the winner. QuickPerform offers the possibility to check the problems related on the queries. The other ones, not. Just analyze a part of your application or the microservices, the different layers with JFrogUnit, or the entire application with Kotlin. You have a big level of detail in that more language. In this case, JFrogUnit QuickPerform offered to you the possibility to understand where could be the problem using different languages like that are based on JVM, like Java, Scala, Kotlin, Clojure, Groovy, and many others. Kotlin and JMeter offer the possibility to know, okay, this endpoint have a problem on performance. Why? I don't know. In which part? I don't know. I only know that if you send a lot of requests to this endpoint, something will happen, and that's it. Support application or testing libraries. Only QuickPerform offers the possibility to use with other frameworks that most of the Java developers use. Java, Kotlin, Scala, all the things use it. And you have the possibility to use with Quarkus or with Spring Boot. So we have the possibility to interact and know what happened behind the scenes. And the last one is running outside of the application. And the winner in this case is Kotlin or JMeter, because the other two cases you need to add inside of your source code to have more detail. If you don't put inside of the application, you lost the detail of the problem. So it's like a big overview about the problems. So which are the pros and the cons of this amazing library? Okay, show to us where is the problem, on which part, on which layer, on which query. You can validate the number of queries that are executed. Imagine that you have a block of code and say, okay, this block of code need to execute one insert, one select, and after that one insert. Imagine that, okay, I won't validate if a client exists or not in my database, so I will do a select, and after that, if not exists, I will insert. So you will execute two queries. So you can validate that only in the worst scenario, you execute one select and one insert. Integrate with other frameworks like Spring Boot, Quarkus, and many more. You can check the use of the resources. This is more or less the same that Shapeshare unit offer the possibility to know how many megas or gigas or whatever unit that you want to validate our method allocate to be executed. And which are the problems? Because everything looks fine. You need to have a database because you need to execute real queries to a database. So, okay, you can fix in some way, you can have like a database in some environment like stage or in your machine or in a pipeline, everyone that you want. But the second problem that appears with the use of the database that you need to have a database that are idempotent. So I need to execute the same test many times and nothing will happen with my test. But because imagine you create a scenario where you insert a client and you put like the document number is unique in the database. So the first time that you execute the test, everything will be passed and looks okay. But the second time will produce an exception. Okay, you try to insert in the database the same client that I have now. So this is not idempotent. So we need to find a way to solve this problem. So let's go to see the example. Here is the URL. And on this repository, you will find the following things. You will have an API. This folder contained all the source code or all the problems on the API. Another directory which give you some end-to-end or performance test, like during my presentation that I mentioned, okay, you can do this to detect the problems. You have two different files with the Docker things. And here an explanation about the requirements and the things that you need to check, how you can run an API, and many other things, okay? I include, in the case that you have Linux or Mac OS, I include a make file with some instruction, so you can do make start and will execute some commands to simplify the process of run on most of the things. And here is my API. It's so simple. It's like you have the possibility to create or delete cities, obtain the information about the cities. Here are the information about Buenos Aires, which is the time zone, where it's located, which is the continent or the country that contains this city, and many other endpoints to modify or delete or to insert many cities at the same time, like a bulk. So everything, this is our API, and we need to find problems, and we need to find a way to test our queries. So Here, I will enter on my end-to-end test to show you as the first step, like, okay, how looks like this performance test. We start the process like, okay, we, in a bad way, we start with our performance test. On this folder, I use Kotlin and Karate to create our end-to-end test. Here you have, take some seconds because execute many times the inserts and to check and analyze the results. Okay, my integration, my performance test finish, everything is okay, the percentage and the number of requests that are executed, everything is okay. I will not have any kind of clue about which is the problem on my application. So in the folder of target, you have one, which is Kotlin. And here on the index, you will find the report of the execution. So more or less, you know, okay, how many seconds or how many requests will fail or pass. I have a lot of information here. I don't know nothing about the problem related with my application. So this is not a good alternative. So we need to discard. The second one, okay, we close. And here, the second one, here we have a logs file, a logger. And I will change the level of detail to debug. And I will stop my application. I will start again. And on the different layers, I include logs to see how many seconds or milliseconds takes each layer to be executed. So the idea is to find more clues. Okay, I will stop this and I will do again this operation. Okay, if I go, I execute it, I will go here, and here I have some information. Okay, I know that this layer takes 34 milliseconds to be executed. The controller takes 107 milliseconds. So now we have some kind of clue. Are not relevant, but more or less we know on which part of the application could be the problem. The next one, here I have the possibility, to explain to the application that, okay, show me the queries that you are executing each time that invoke an endpoint. So you have more or less some kind of clue about which could be the problem or where could be the problem. So I execute again, and here, sorry, I missed something. Okay, I do just a simple operation, and as you can see here, you have two different queries. One to obtain all the information of the city, and another one to obtain the information of the country. I have two different queries. And now you have more information about where could be the problem. Okay, it's time to finish this. And now it's time to try to fix this or to have some kind of element to solve that problem. So let me start with, you need to add some dependencies. Sorry, I need to open the folder. Sorry, here, because if not, something bad will happen. I can fix the problem with the source code. Okay, now, here, I need to add some dependencies here on the application. The first one is test container. Remember that I mentioned it about the problems that you need that the test need to be idempotent. So you need to have the possibility to execute many times without affect a real environment. So the good alternative, or the only alternative to do this, is use test container. Test container behind the scenes use Docker, and with Docker you can create a container which contain this one. In this case, my application use MySQL as a database. So you have this dependency, which is the source code or the core of the test container. And after that, you can include many other modules. Each module is connected like with one particular database, or in the case that you need to connect with an external cloud provider like, I don't know, AWS, Amazon, you can use local stack. So this is the first thing. We solve one of the problem. The second problem that we need to solve is, okay, we need to use quick perform and to analyze the problem. So to do this, you need to include these dependencies. There are two dependencies, and why this is so important. Quick perform have a core module, which is this one, which provide many annotation, many things to check. But in the case that you want to integrate with another framework, you need to include this extra module. This is in the case that you use Spring Boot like me. There are another one, which is Quarkus. So this one, or many other things. In the case that you don't know which is the framework that your team use for this application, just ask before to start to do the modification. So, okay, we have the dependencies of test container for our database and the dependencies to quick perform. Great. Next step, we need to start to create a test. And the application in Java, or in the case of a Spring Boot, are split on different layers. The repository are the layers which interact with the database. So if you open this package, you will find this interface, which is responsible to connect with the database and obtain all the information about the table which contains the cities. And you have two different operations. One, which I send the code like 𝐴 in the case of our example, and return me the information about that city in the case that exists. And the other one is to delete or modify a record in the database. These ones are totally optional, because in the case that you don't write this method, this interface will provide you a lot of default methods to access. So it's just a brief explanation. Let's create a city repository test. Okay. So now that we created, we need to start to do things. Let me, to simplify the process, I will include all the import just for reduce the problems. I need to reload here the dependencies. And okay, I need to include some things. First one, I need to include, okay, I need to run my application. This application uses Spring Boot. Okay, I need to include this annotation. After that, I need to indicate that my application, or this test in particular, will use some features of test container. And after that, you need to indicate that this test need to use or will use some part of the quick perform. This annotation in particular say to the class okay, all the tests that exist on this class, all the tests that you created will be executed using quick perform, and you will analyze something. What things you will analyze? Well, here, you will analyze the SQL queries. Okay, next one. I need to declare that I will use my repository. And here will start the magic of the situation. I will declare a container here, an MSQL container, which use this password, and I will use this particular version of MySQL, and the database is with this name. And here appear this. And why this is so important for us? Well, the main problem is if you don't use these kind of things, imagine this, each time that you run the test, you will start a container. So you start a container, execute everything, all the tests, and stop. So if you have 10 classes that need to run a container, you start and stop 10 times. With this method and put on true, you indicate to the environment of Java, okay, perhaps someone of all the other classes need to execute this container. Just in case, keep alive until that the execution of all my tests finish. So in the case that other classes need to execute the same container, instead to start, we'll reuse the same container. It's just to not spend a lot of time to execute something. And of course, we need to start the container because we declare, but you don't do nothing. And the last step, this is so general for all the cases. So I try to explain. After that, you need to declare a method which is responsible to override the default configuration of the application, because all these things are dynamic. The JDBC URL, the password, and the username are dynamic, are not in the file I declare or I use another ones. So all these things are needed to execute. After that, here start the magic. I create a simple test. If you know more or less, JUnit 5, because you see the test of any developer on your company, or you create a unit test, you use this. So let's start with the notations related with this. And I will add the annotations. This one is from JUnit 5. It's nothing strange. And here I declare that this method that you will use a repository will execute just one query, and I want to analyze the results. If everything is okay, if I run this, will take I can find the logs. Give me a second, because it's a problem with the where is I want to find the solution. Sorry for the delay. This could happen, as I always say. if someone have a question in the meantime, because I want to answer here. Sorry, I found the solution. My fault. Here, sorry. Now it's okay. Okay, now, sorry, because it's the problem is connected with Docker. So this will take some seconds because we'll download the image from the repository and we'll execute everything. Now, as you can see, I executed my application and this will fail. Why this will fail? Because execute two queries as we see in our example. So this shows you that something is bad, how many seconds takes to execute the query and the queries that are executed. So you can create tests that check these kind of things. And just another one, and I think I have time to execute. This is more or less the same, but in the case of insert. So these kind of annotations are more or less the same in all the cases. So you have insert, select, delete, and update. And in this case, we'll execute just one query and take less or more or less 1 millisecond. So in the case that something like this happened to you, that appear a problem with the performance of your queries, try to send this problem, just you only put the emphasis or the focus to create tests and nothing more, and delegate to the developers or the DBA the responsibility to detect how they can fix the problem on the queries. Don't put a lot of effort, okay, the problem could be this one or this one, no. So I think with this, we more or less cover the topic or the basic ideas of the topic. I don't know if we have some questions to answer. If not, I will continue with a short example. I don't know. If not, I will do another example that represent more or less the same. Here is another layer. So you have the layer that is responsible to access to the database. This is the repository, and the services is a layer that is up to that. And I will use the same declaration. Everything it's okay. It's the same. Just to finish, you can combine two different annotations. In the case that you have a class that use or execute many queries, you can combine all these things. So if you execute, we'll check if everything is okay. We'll check if an insert and a select will be executed. And just to finish, because I don't have too many time, best practices, always have tests, create tests just for the complex query, not for everything. Check with the database, your DBA, if you have doubts about your queries. Run the query test in a pipeline, not delegate the responsibility like you execute this command and something on some situation, execute all the time. Create a performance test is a good way to detect problems on production, and define alerts that detect this problem and report you in some way. Additional resources, here are some books and blogs which help you with these problems. So it's time the questions.
Yep. Thank you so much, Andres. That was an amazing session. Now we can let's hop on to Q&A section. I'll just put on the questions on the stage for you now.
Okay.
So the question is, did you encounter any unexpected or counterintuitive performance challenges related to the database interactions? How did you go about the diagnosing and addressing these challenges?
Okay, the main problem with the interaction with a database is you will affect in some way the performance of some environment. And so when you create a performance test, you need to find a way will not affect some real environment like a stage or something like that. So the main problem or the big challenge of this is, okay, how I can reproduce the same environment and execute my performance test without affect the entire platform or the entire database. So the unique way is find an alternative, not wait until that the problem appear and you miss the database from the stage or pre-prod or some of these environments.
Okay, let's move to another question. Is database testing what all just in database testing what all things are required for writing good test cases?
In the case that you want to test a database, I think you need to check the number of queries that are executed and the duration. And if you want to be more precise, you can check the allocation of resources. There are one annotation on quick perform, check the official documentation is measure allocation, and you can indicate how many megabytes or gigabytes or anything that you want are allocated to be create this test.
Okay.
So with these two things, everything is okay.
Let's move on to next one. What steps have been taken to address and resolve the issues encountered with the queries, and how do you plan to ensure the stability and efficiency of the query system moving forward?
Great question. In the case that you are a QA or a tester, your responsibility is only to detect the problem, create the test, and send your merge request or push your test on some branch and delegate the responsibility to a tester, to a developer to find the solution. Because in some cases that, as I show you, the solution is just change a value in one annotation of the source code, but it's not your responsibility to find a solution. It's just say, okay, I create a test and I detect this kind of problem. I detect a problem on the use of resources, or this query takes a lot of seconds to be executed. Fix it. You write the test and nothing more, and send the information to another one. Could be a developer or a DBA, depending on the complexity of the query, of course.
Let's pick up the last question now. That is, what will be the chaos testing scenario for database testing?
Not more or less not the same. Chaos testing or chaos engineering, the test that what happened in the case that will stop a database or something bad happened with the database. In the case of this kind of test, we assume that the database is okay and the problem is in some part of our source code or the query or the number of rows that we try to obtain or something like that. We check, someone in your team could, DevOps could check if the database is okay, have a good memory and a good CPU, so it's simple to check. The problem is totally different. In our case, the problem is our application, not the database.
Okay, once again, thank you so much, Andres, and also a big thanks to everyone who has joined this interactive session. Unfortunately, we're not able to take all the questions, but don't worry, we have a Lambda test community thread also going on where you would be posting the answers to these questions as well. So feel free to add in your questions over there. Also, just a heads up, we are about to start the Fluid space. So guys, Andres is available there. You can just join in the session and you can have the Q&A section with him there also. Thank you so much. Happy testing.
Thanks. Bye.